Today, we're going to create this animated loading indicator. Let's go. So we're in the middle of a series of videos on creating procedural shapes and patterns. The most valuable thing about this series is that I'm showing you how to create a set of subgraphs in Unity and material functions in Unreal that allow you to very quickly create effects like this, just chaining the nodes from the library together. Today, I'm going to show you a good example of that. We're going to create this animated loading indicator using 5 of the nodes from the library that I've already explained how to make in previous videos in this series. If you take a look down in the description, I've linked a playlist there for all of the videos in the series, and I've also created a list of all of the subgraph nodes that we've created so far, along with a link to the spot in each video where I show how to make it. So, in this video, when I mentioned the circle node, the grid tiles node, the scale node, and the rest, you can find a link to my tutorial on creating each of those in that list in the description. Okay, let's get started making this animated loading indicator. Okay, so the first thing that I'm going to do is come down here to my folder structure in my project window, and I'm going to select my shaders folder here. And in this series, we've already created the lava lamp and the 80s sunset. And this time we're going to create a subgraph called simple loading. So I'll just come over here to shader graph, subgraph, and call it simple loading. And we'll open up this subgraph. And to get started with our pattern, the first thing that I need is a circle. So I'll just type circle. And this circle SDF node is one that we've created in a previous video. Like I mentioned, it'll be down in the description where you can see where to create this node. All right, and I'm just going to set the default size of our circle to 0.4 just to shrink it down just a little bit. And that's going to allow us to have some space in between the chain of circles that we're going to create. So speaking of chain of circles, the next thing that we need to do is to create multiples of this circle. And we're going to do that with our grid tiles node that we've also created previously. So this node takes UV coordinates and splits them up into a repeating grid. And in order to create the number of grid tiles that we need, we actually need to add our first parameter. So I'm going to open up my Blackboard here, and we'll create a new parameter. It's a floating parameter, and we're going to call it segments. And this is the number of circles that are going to be in our circle of circles. And I want to default my segments to a value of 18. So I'm just going to come over here to the default value and type 18 there. And then I'm going to drag my segments parameter in. And we're going to use this segments parameter for the number of tiles in the V, or the vertical number of tiles. So I'm going to connect that up right there. And we're going to set our horizontal tiles to 1. So now, if we connect our grid tiles to our circle pattern, now you can see I've got a really nice chain of 18 circles that are chained together vertically. So the next thing that I need to do to create this pattern is I need to wrap these circles around in a circle. And in order to do that, the node that we use is called polar coordinates. And so I'll just type polar, and there's my polar coordinates node. And this is going to allow me to create a circle. What this does is it takes UV coordinates that are laid out in a grid and wraps them around in a circle. And for this value, I know that I need a radial scale of 0.65. So I'm going to type that there. And now I can connect up my UV coordinates here to my grid tiles. So instead of a square grid like this, I'm going to end up with a circular grid like this. And now you can see what's happened to my circles is instead of being in a vertical line like they were before, now I've got them wrapped around in a circle. But There's one problem that you can probably see here, and that is that the circles have become stretched. And so the next thing that I need to do is fix that. And I'm going to fix that by adding a scale node here in between my polar coordinates node and my grid tile node. I'm going to add a scale node. And this node here is one that we've created in a previous video, and again, it's linked down below. All right, so I'm going to plug my UV coordinates into my scale node there. And then I'm going to set my scale to a value of 3 and 1. And what this is going to do is it's scaling the UV coordinates that are going around in a circle here so that I can unsquash my circles over there. So I'm going to plug these UVs into the UV node. And now you can see I've got a little bit better shapes for my circles. Okay, now that we've progressed this far, the next thing that I want to show you is that if we take our segments here, we can set this segment's value to whatever we want. So this is something that you'll be able to control. Say you only want 5 circles. You can set segments to 5. You can set it to 8. Set it to 10. You know, you can customize this value however you want, but I'm going to set it to 18 just because I found that looks the nicest. Okay, so we've got our really nice circle of circles here. The next thing that we need to do, well, actually, before that, can you see how our circles are kind of aliased and chunky looking? Let's fix that really quick. So I'm just going to take my circle here, and what it's previewing here is the value that's coming out of fill. And instead, what I want to do is use the value that's coming out of SDF. That's our signed distance field. And in order to make our circles a little bit smoother, I'm going to use an anti-aliasing node. This is one that we created in a previous video. And I'll plug in my gradients here. I'm going to set my cutoff to 0. And then I'm going to add a 1- node to invert our results. And now we have some circles that are a little bit smoother. There is some chunkiness here, but that's just because our previews are kind of low resolution. If you actually see this applied in your project, it'll be nice and smooth because you'll be using the resolution of your screen rather than the lower resolution of these thumbnail previews. All right, so that is our anti-aliasing. And we've created a really nice smooth circle of circles. The next thing that we need to do is create the animated mask that makes it look like our circles are going around in a circle. And so let's do that next. And drag out our scale value. And we're going to add a split node because we only want the V coordinate. We have U and V coordinates coming out of here for our UVs. And we only want the V. That's the gradient that goes around in the circle. And we're going to connect this to a fraction node, which is going to make that circle gradient a value of 0 here. And then it increases as we go around the circle. And it ends up with a value of 1 on the other side, meeting up with a value of 0. So we go from 0 all the way around the circle to 1. And this is the mask that we're going to use for the animation of our loading indicator. The next thing that we're going to do is we need to bring in time. And I'm going to use a node called linear time that we've created previously. So this is our linear time node. You can see as our time is represented here, it goes from 0 and then it slowly ramps up to 1 and then jumps back to 0 again. For our speed of time, we need to add another parameter for that. So I'm going to come over here to our blackboard and add a float parameter, and we'll just call this speed. And I'm going to set the default value of speed to 1. So we'll grab our speed parameter, pull it in, and connect it up to our linear time node. And now we've got our time moving along there. And the next thing that we need to do is we have 18 circles here, and we need to split time up into 18 discrete steps so that instead of rotating smoothly, we're going to go in 18 steps. And so in order to do that, we're going to use the posterize node. So this node splits up data into discrete steps. Right now we have a nice smooth gradient where time is advancing from 0 to 1. And we want to split this into steps. So I'm going to connect our linear time loop output here to the input of our posterize. And now you can see that time is advancing in 4 discrete steps. Boom, 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 like that. And what we want to do is instead of using 4, we want this to use our segments value. Right now this value is set to 18. So I'm going to plug this in. And now it's a little bit less obvious because there are so many steps happening here. It looks smooth, but trust me, there are 18 steps happening here. Okay, so we've got our time, and we posterized the time so that it's split into the number of steps that we have circles in our pattern there. The next thing that we need to do is take our time and add it to our gradient value. So I'm going to grab these values here, and we'll just throw in an add node. And then we'll connect that up here. And now what you can see is our values are increasing. And what I need to do is connect this now into our fraction. And now we have a really nice pattern, and it looks like our values are going around in a circle. I could sit and stare at this all day. This is a really cool thing. You might say, oh, that looks like a radar. We could create a cool radar effect with that. And you're right. We may do that later, but that's not what we're working on today. The next thing that we need to do is take our pattern, and just like we posterized our time here into 18 discrete steps, we need to posterize our values as well. Right now we've got a smooth gradient, and what we actually want is a chunky looking gradient that has 18 discrete visual steps as well as temporal steps. And so we're going to use another posterize node for that. I'll bring in posterize and connect that up. So now you can see we've posterized our gradient into 4 steps, but we actually need to posterize it into the number of segments that we have. So I'm going to connect that. And now you can see that we've got 18 discrete visual steps. And this is what we can use as a multiplier mask with our circle of circles to create our animated effect. So I'm going to bring this over here, and we're just going to multiply the animated mask that we created with our circle of circles. And now we've got our great looking animated loading indicator that will tell the user, hey, hang on, something's happening in the background. Wait just a minute, and it'll be done. So we've used math, and we've procedurally generated our animated loading indicator. Now, the last thing that we're going to do, just to add a little bit of polish, is I'm going to add another parameter here for color. And I'm going to set, I'm going to make it so that the user can use this subgraph to make their loading indicator whatever color they would like. So in order to do that, we're going to add a lerp node, and we're going to blend between the background color, which in this case is 0, and the foreground color, which is going to be the color of the dots, based on this mask that we've created. So our T value is the animated mask, our B value is our input color, and our A value is black. And now we can set a default color. So let's grab our color parameter here and maybe set maybe a nice blue for our loading indicator default. And obviously the user can set this color to whatever they want it to be. All right, let's connect up our output to our output node there. And we're going to set this to a vector 3 because it's just a color there. And we'll just call it out. And there we go. We're all set. Now there are just a couple of touches like we always do. We want to set up a couple of more parameters just to make this more user-friendly. We're going to add in a UV coordinate node. And we'll set our UVs to use custom binding. And we'll set our label to UV0. Then we'll bring in our UV coordinates. And we'll add a branch on input connection node so that we can make our UVs default to UV0 when nothing is connected. And then we'll connect this up as our UV coordinates. And we're also going to come up here to our paths and set it to the example path. And in our graph settings, we're going to set the preview to 2D. And we're all done. Now we can use this subgraph in another shader. We can add it in and combine this effect with any other effects that we have to create our nice loading indicator. Okay, let's switch over to Unreal and I'll show you how to do this same thing there. All right, here we are in Unreal to create our simple loading indicator. But before that, there are two nodes that we need to create that are available in Unity but not in Unreal. The polar coordinates node and also the posterize node. So let's go ahead and create those first. And then I'll show you how to use them together with the other nodes we've already created to create that cool loading indicator. So here's my directory structure. I'm going to come down here to my UV folder and right click here and we're going to pick material function. And we're going to call this polar coordinates. And this is the node that converts a grid set of UV coordinates to a circular set of UV coordinates. And so in order to create this node, we first need an input. And this is going to be the UV input. So I'm going to call it UV. And we'll set it to be a vector 2 for U and V. And I'm going to pick the use preview value. And then the other thing that we need to do is bring in our texture coordinates. These are going to be the default input for when our UV input is empty. So these are going to be our grid-based square UV coordinates. And then what we're going to do here in the node is convert them to radial or circle-based UV coordinates. So the first thing that we need to do is center them. And the way that we're going to do that is by subtracting 0.5. So we'll type 0.5 for A here and then connect our input UV coordinates. And what that does is it puts the center of the UVs in the center of the grid there instead of the center being in the corner. All right, the next thing that we're going to do is we're going to split this out and we'll create, what we need to do is create two different gradients. One that tells us how far away from the center we are, and that'll be our U. And the other one that tells us how far around the circle we are, and that'll be our V. So figuring out how far away we are from the center is really easy. All we have to do is measure the length of our vector. And what this length node does is that it creates a value that is 0 in the middle, and then as we get further away from the middle, that number increases. In this case, we're going to take our length and multiply it by 2. And then we need to add some user control here so that the user can scale this value in and out. And so we're going to add another input. There's our function input. We're going to set this to be a scalar. And this is going to be our radial scale, or how far away from the center we are. We're going to default it to a value of 1. And check the use preview box there. Okay, so now for this input, all I need to do is multiply it by our distance value that we've already created. And now we've got our first value here. This is our distance away from the center, and we can control it based on our radial scale value. Okay, the second half of this is the v coordinate, and it's the distance for how far around the circle we are. And it's a little bit more complicated to compute. So we're going to add a breakout float to components node here. This is going to give us our u and our v separately. And now we need to do an arctangent operation. This is a trigonometry operation. So we're going to find the arctan2 node. And because we have a limited range between -1 and 1, Unreal actually provides this other node called arctangent2 fast, which is an optimized version of the arctangent calculation that basically just does it faster if your range is limited. Arctangent is for like any range, but if you know you're going to be in between -1 and 1 or a very narrow range, you can use this arctangent2 fast node, and it'll do that math faster for you. So we're going to plug in the u here and the v here to do that arctangent calculation. And then we're going to divide the result by tau, which is 2 pi. So I'm going to divide by 6.283 and just kind of round pi there. Okay, and then let's see what we get as a result of this. So you can see we're going from a value of 0 here. Actually, it goes from a value of -1 here around to a value of 1 there. So we're going all the way around the circle, and this kind of tells us how far around the circle we are. Now, in order to give the user a little bit more control here as well, we want to add another input. And in fact, I think I'm just going to copy this input from up here. Here's our input radial scale. And instead of radial scale, we're going to call this length scale. All right, we're going to default it to 1 and check this use preview value. And then we can just multiply our input length scale there by the value that we computed. Okay, so we've got our two different components, and now all we need to do is append them together. So I'm going to add an append vector. This is going to be my u, and this is going to be my v, and it's going to look something like this. So our u value tells us how far away from the center we are, and our v value tells us how far around the circle we are. So I can just take this value and pass it out, and we'll call this our out value. The last thing that I want to do, there's just a couple of cleanup items. I want to make sure that our values are in the right order. So this is our first one. We'll set sort priority to 0. Our second one, we'll set sort priority to 1. Our third one, we'll set sort priority to 2. And now we want to make sure that our material function is exposed to the library so that we can access it from this menu here. And we want to make sure that it's in the right place. So we're going to type procedural/uv, and that'll put it in the right place in the menu. Okay, so we can save that, and we're ready to create our next material function, which is the posterize function. And we're going to put posterize in the helpers folder. So I'm going to right click in here and pick material function, and we're going to call this posterize, and this is going to be the node that splits up our data into discrete steps. So in order to do this, the first thing that we need is an input, a function input. So this is going to be our gradient input, and we'll just call it in. And we're going to set it to use preview value. And for the default, let's bring in our linear gradient node and set it to our u gradient. So that's going to be our default gradient. If nothing is connected here, we're just going to use our horizontal linear gradient. All right, the other thing that we need for inputs as a function input, and this, instead of being a vector 3, we're just going to set this to be a scalar. All right, and our other input that we need is called steps, and it's the number of steps that we're using. So we're going to set this to be a scalar. We'll default to a value of 4 and set use preview. Okay, so what we're going to do is take our input gradient and split it up into, kind of quantize it, I guess, is another good word for that. Split it up into this number of steps. And this is pretty easy to do. We just multiply the gradient by the number of steps. And so now instead of going from 0 to 1, it's going from 0 to 4. And now we're just going to round down to the nearest whole number. And so this is going to be 0, 1, 2, and 3. You can't see these here because this only goes from 0 to 1 in the preview. But in order to convert this back to a value of 0 to 1 and maintain our quantize, we just add a divide here and divide by the number of steps. So we'll add in our divide and connect up our number of steps. And now we've rounded down to the nearest whole number and then divided by the number of steps. So now we have our posterize complete. We've split this up into 4 equal steps. So we can just connect that up to the output and we'll just call this out. All right, and then we can check the expose to library button here and we'll set the path to procedural / helpers. And we're all set. We've got our posterize and we've got our polar coordinates node. Well, all right, let's come down here to our content drawer and go to shaders here. And we're going to create a new material function. And this one we're going to call simple loading because it's our loading indicator. So we'll open up and get started. So first we need a circle node. And now our circle node is in our menu because we've turned that on. So here's our circle. And if we just wire this directly out, you can see we've got our nice circle there. The only thing that we need to change on our circle, actually let's update our preview over here so that we can see this a little bit better. The only thing that we need to change on our circle is the size. We're going to set it to a value of 0.4. We'll just connect that right up to the size. All right, the next thing that we need to do is we want to create a series of circles instead of just one. And in order to do that, we're going to change the UV coordinates that are coming into our circle. So we're going to use the grid tiles node that we created previously. So there's our grid tiles. And what this does is it tiles UV coordinates. So we're going to hook up our scaled pattern UV output to our UV input. And now you can see I've got a nice grid of circles. So this is pretty cool looking, but I actually don't want a grid. I just want a long row. And so in order to do this, we want to set our number of tiles in the U coordinate to be 1. All right, so now I've just got a nice row there. And we want to set the number of V tiles to a specified number of circles. And so in order to do that, I'm going to add an input, a function input here. And we'll set it to scalar. And we're going to call it segments. This is the number of segments that we want, or the number of circles. And we're going to default this to a value of 18 and check this use preview value as default. And now we can plug this into the tile V. And now we've got a nice row of 18 circles. That looks great. All right, now that we've got our circles in a nice vertical line here, the next thing that we want to do is make a circle of circles. And how are we going to do that? Well, we're going to go back and use the polar coordinates node that we created just a minute ago. So I'm going to come over here and we're going to do a search for polar coordinates. And there it is, comes right up. And so now all I need to do is plug this polar coordinates output into the UVs of the grid tile that we created. And we get a nice circle. Now it's not looking exactly the way that we want it to. Our circles here got a little bit squished and maybe they're not quite the right size. So let's add just a couple of adjustments. For our radial scale, I'm going to want a value of 0.65 instead of 1, which it defaults to. And then we need to add another value in here to scale our polar coordinates. And so I'm going to add our scale node. That's one of the nodes that we created previously. We'll plug our UVs into that. And then for the scale value here, we're going to create a vector 2, and we're going to scale this by 3 and 1. So we'll plug this into scale, and then we just need to plug our scale value into our grid tiles instead. And now we've got a nice mask of 18 circles around in a circle. So we're making some great progress. The next thing that we need to do is create the animated mask that looks like the circles are going around. So in order to do that, we're going to grab the UVs coming out of our scale value here, and I'm going to add a component mask, and we're going to filter this out so we're just grabbing the second component, or the V, and our V looks like this. This is kind of our gradient that's going around in a circle. Now to get this the way that we want it to be, I'm going to add a frac node here. And now you can see, instead of going from -1 to 1, we're actually just going from 0 to 1 around in our circle. Okay, so we've got our mask, and this is going to create our animation. But in order to animate it, we need to bring in time. So I'm going to bring in our linear time node that we created previously. And for the speed, we want a parameter to control the speed. So I'm going to add a new input function, or function input. And we're going to call this one speed. And we'll set it to a scalar, and I'll give it a default value of 1. And this is the value that's going to control how fast our time is progressing. So the next thing that we need to do, this time proceeds in a very smooth linear fashion. And we actually want time to be split up and posterized or quantized into individual chunks. And so in order to do that, we need to bring in the posterize node that we created just a minute ago. And so we're going to pass our time into the input parameter here. And actually, these are out of order. I want to make in come before steps. So let's open up our posterize node and make sure that these are in the right order. In's going to be a sort priority of 0, and steps is going to be a sort priority of 1. So now we'll bring in posterize, and we got things in the right order, and the number of steps is going to be the same as the number of segments. So I'm going to bring this guy over here and plug that in. And now, instead of time going linearly, it's jumping in a series of 18 segments. And that's what we want to be able to do in order to make this thing go around the circle, kind of divided up into the 18 discrete steps. Okay, so now that we have these values, we can come over here and just add them right here before we pass our data into the frac node. So I'm going to add this circular mask here to our time value that is quantized. So I'll plug this in, then plug it into the frac. And it looks like we're still not getting our animated updates. I'm not really sure why that is. Oh, I found the problem. It's because we plugged our speed into the in here instead of to the speed. So if we plug this in here and disconnect that. All right, yeah. There we go. You guys probably caught that mistake a long time ago, and you're screaming at me through your monitor, hey, fix your mistake. Okay, so there we've got our quantized animated pattern, and that's looking pretty cool. So the next thing that we need to do is quantize our gradient. So we quantize time, so it's doing 18 discrete steps. But we also need to quantize our gradient because it's actually too smooth for the effect that we're going for. So we need to add another posterize node here, and we'll be done. So I'm going to bring in our posterize node again, and we'll plug our frac into in. And the number of steps is going to be our number of segments here. And now that we've got this posterized, if we preview our result here, now you can see our gradient has been quantized into 8 different grayscale values. And that is the look that we're going for. Okay, I'm just going to clean up my grid just a little bit and kind of reorganize things here. And I realized there was one thing that I forgot to do when I was creating the circle SDF, or the circle shape here, and that is I forgot to add our anti-aliasing. So we're going to add our anti-aliasing node and connect our SDF coming out of the circle to the gradient there. Then we're going to set our cutoff to 0. And what this is going to do is just, instead of these really chunky looking circles, if we preview these over here, you can see that the edges of our circles are aliased. And what we can do instead is use the output of this anti-aliasing node, including a 1-. And that's just going to apply anti-aliasing to the circles and make them look a lot nicer. All right, and now I just need to take that animated mask that we created down here and multiply it by our circle mask here. So I'm going to add a multiply node here at the end and multiply it by our animated mask and plug that into our output. And now we've got our cool animated circles. We're going around in a circle here. It's quantized into our 18 different steps. And we've got this really nice animated pattern that indicates to the user that, hey, hold on, the machine's doing something. You just need to wait for a minute. Okay, we're almost done. The last thing that I want to do is add in a color to allow the user to adjust what color our indicator is here. And so in order to do that, I'm going to add a lerp. And we're going to lerp between black and the color based on this mask that we've generated, this animated mask. So I need to add a new function input. And this one's going to be a vector3. And we're just going to call it color. And we'll plug in the color to the B value of our lerp. And we can plug our lerp into the output. Instead of result, I'm going to call the output out. And let's clean up some things here. Let's say our default color is going to be, well, let's just figure out a color that we can use for default. Maybe just kind of a blue shade like this. That should look nice. We can plug that into our preview and then make sure in our output color here we check this use preview value as default. All right, so we've got a nice blue shade going on there. We've got our nice animated effect. Last couple of things, we want to make sure these inputs are in the right order. So we're going to put our color first. That's going to be 0. And we'll set our segments next. That's going to be 1. And our speed is going to be 2. And then we also want this to appear in our menu. So I'm going to pick expose to library. And we'll type procedural/examples. Yeah, cool. And we're all done. So there is our procedural loading indicator. And it's pretty cool. What you can see is that we've used this library of nodes that we're building. We used our polar coordinates, our scale, grid tiles, circle. All of these are really nice shortcuts. So when it comes time to build your own pattern, like what we've created here, it becomes really easy because you've got this library of material functions that you can really quickly throw together instead of having to reinvent the wheel every time. So I hope you enjoyed the video, and I hope this is valuable to you and that you see the value in creating this library of nodes that's designed specifically for creating procedural shapes and patterns. All right, next week we're going to keep going with this series. We're going to create some new material functions to add to the library and some new example patterns using the functions. In the meantime, have a great week, everybody.